Yes, screen is right. Share screen. And yes, stream has started. Good. So today's contest, there were two big jumps of songs, and let's start. So Alice and Bob are playing a game. If and basically A of I not equal, like all the AI values are distinct and all the cards are face up. Alice will choose one card and remove it. Then Bob will choose a card, and Bob is greedy. What he'll do is he'll choose the maximum AI among all the remaining cards. And now after choosing X and choosing Y, Alice will win depending on this condition. Is there a way to for Alice to choose a card? Okay. Now I'll just write it like this. Let's take an example. This. So now this is my A and this is my B. Now if I sort my A, okay, what will I get? Yeah. If I sort my A, I'll get 1, 3, 4, 5. Below I'll get 7, 5, 6, 2. Yeah. So this is after sorting. Now, if I'm taking this number, if Alice is taking this, Bob will always take this. Correct? That is given in the question. And if Alice is taking this, Bob will take this. Cool. So a very simple and a straightforward way to do this is let Alice choose this. Will Alice win? Yes, no. Then let Alice choose this. Let Alice choose this. Let Alice choose this. Simple brute force. Like if Alice is choosing this, let's say what happens. So what my code does is I'm sorting with respect to the first value. Now my last value is my max. No, this last value Bob will always pick if I'm choosing any of these three indexes. So that is my maximum value, and that maximum value is what? Last of 0, comma last of 1 ka max value. Now for all 0 to n minus 1, my Alice's score is what? Max of I comma 0 and I comma 1. And I just check that condition. If it's yes, print yes, or else return and return. Or else just continues this loop. Now at the end, what will happen? This is Alice, and this is chosen by Bob. So I'll check, no. Last value, this max, so that is max. And the second last value is what Bob chooses. So second last value ka maximum value. I check with the condition and just print yes. No doubts? Hello. Cool. I guess no doubts here. Let's move on to red blue sort. This is a very good problem and like yeah, like fun problem. It is. Uh, 5, 4, 1, 2, 3, 5. Yes. Okay. In the question, what is mentioned is you're given a permutation. Now, first you choose a subset. Now, it has to be of some size. It has to be either 1 or n minus 1. It can't be the entire array. Now you need to paint all the indexes you choose as red, the other as blue, and then you ascending, descending. This is a bit complicated. Operation costs 1 coin, and I'll just explain it with an example so it's more clear. Okay. Let's say I choose this, I choose this, and this one. Okay. These are my red. Okay. These are my blue. Blue. What will happen is after choosing, the red ones get sorted in place. So at these indexes only it gets sorted. So 2 comes here. Let's leave this as blank. 3 comes here and 4 comes here. Okay, this is ascending order and blue is descending order. So 5 comes in place of 1 and 1 goes in place of 5. Okay, this is after I choose this particular set of subset of numbers. Okay, now if this constraint was not there, I would always choose the entire subset and just sort it in one step. Okay, so that is, yeah, that they don't want to do, that they don't want us to do. Okay, now at the end of the day, this is the operation ka cost and how it works. It costs 1 coin. Now the question states, given a PI, you want to earn maximum profit, and maximum profit is when 1, 2, 3, 4, 5. Basically, it is in sorted order. That's it. That is when you'll gain the maximum profit. Okay. Now, how do I convert from this to this in and basic in minimum operations? If I do minimum operations, I know this is the maximum profit I'll get. If I choose this minimum operations ka value, if I somehow figure this out, then the question is solved. Okay. But how do I choose, like, what is the minimum number of operations? Cool. Now, let's just notice something. Okay. If I place a 1 here, okay, let's let me give it for 1, this one. Okay. Yeah. Now, since red numbers I'm sorting in ascending order and blue numbers I'm sorting in descending order, I would like to choose all the numbers as red, right? That is the best case. But one number I'll have to choose as blue, minimum, at minimum one number. Which number will I choose as blue? A number which is already in correct place, if I just choose it as blue, all the other numbers will get sorted automatically. Yes, no? Hello, anyone?
Yes.
Yeah. So if I get any index where the actual position is correct, then to in one operation, I choose all these as red and I make 1, 2, 3, 4, 5. Fair enough? So this takes me 1 coin. Okay. Now what are the other case? Let's say it was already 1, 2, 3, 4, 5. Then it takes me 0 coins. Correct? Now if I don't have any, either this or this, meaning let's say it is 4, 5, 2, 3, 1. Now no person is at the correct spot. Then what do I do? If I choose a 1 and the first index as red, what will happen? Others I'll choose as blue. Doesn't really matter what happens to the others, okay? But what happens is 1 comes to the first place. Fair enough? This becomes 5, 3, 2, 4. Yes, no. Basically, I'm choosing the red numbers as first index and the index where 1 is. Okay. Now, since I have 1 as fixed, I can choose another coin, right? Yes, no. Hello. Basically, so yeah, these are the only three cases. If it is already sorted, you require 0 coins. If it's or not sorted, but one place is correct, then it requires me 1 coin, or else it requires me 2 coins. Basically 1 plus 1. So how do I code this up? That is where the code comes in. It's pretty straightforward. Firstly, I'll check if it's already sorted. So first my flag is 0. If any number is lesser than its previous number, that means it is not sorted. Fair enough. If it is sorted, meaning flag is 0, then I just print n because that is the profit I gain. Now I do another check. If any person is at the correct place, I set flag to 1. Okay. And my answer is what? N minus 2 plus flag. It's just the same as saying, now this is taking n coins, right? N minus 2, it's taking for this. I'm removing this one step. That's why I'm doing plus 1 if flag is 2. So that's it. Pretty straightforward code. Any doubts? Yes, no? Tell me then. Okay, cool. Let's move on to temperature, temporary temperature. This question, a lot of you were stuck at, like there was a drop here. So I'll explain this in a bit more detail. I myself solved this after solving E, after solving D, after solving E, I solved C. So yeah, technically I found it harder, but it just, if it clicks, it clicks. If it doesn't, it doesn't. So I'll explain what is this and how do I do this. So firstly, let's take a test case. Okay, these are my AIs. Okay, this is my desired temperature for each step. Okay, desired temperature. Now let's say I have a BI, B, X, 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 X. Okay. Now, what is my cost? What is my, wait, this thing, this. What is the minimum possible unsavoriness? What is unsavoriness? Basically, if I subtract, basically for all I, max of abs of BI minus AI. This is basically given over here. Max of AI minus BI, absolute value. So that is it. Now, this is my unsavoriness. Okay. Now what it also says is I have k changes I can make. Okay, up to k changes I can make. Changes meaning, let's say I have one change, so I can do this like this: XX, then Y, then Y. Okay, this is one change. Okay, one change. If I have a Z here, then it is two changes. Okay. For now, let's just say I have zero changes to do. What is the value of my X? Can anyone tell me? What is the best value of X I can have? बोलो.
सॉर्ट करके आई गेस मीडियन वैल्यू.
Median value, fair, but also I like another like median value is good. Like yeah, good thing is if I'm taking sum of abs of di minus ai, then I'll take median or average. I'll take the median because median will help me reduce the sum. Fair. But since it is maximum, it's better for me to do max plus min by 2 because the elements in between won't really matter for me. Whatever their difference is doesn't really matter. The difference with max and min matters, right? Because that will be my maximum unsavoriness. Yes, no. Hello. You were saying,
गॉट इट.
yeah. So this is my best X I can have for a particular range. Cool. But now the question is not just print this X, no. I need to print with K changes. What is the minimum unsavoriness? So this is where binary search comes in. This is a very standard problem for something called binary search on answer. Like very standard problem as in from the question itself, if you've solved a lot of binary search and answer questions, you might notice it is a binary search and answer. But always a problem in binary search and answer is what is the check function and is it bipartite? Okay. These are the two things we need to check if I want to do binary search and answer. This is the first thing and this is the second thing. So what is bipartite? Bipartite is basically bipartite or you can say huh, like bipartite or just increasing. Okay. Yeah. Now, let's say I have a lot of zeros and then lot of ones. Okay. This is basically an increasing or a bipartite graph. Bipartite graph meaning there is a barrier where all the elements below it are 0, all the elements above it are 1. Okay. So I just need to figure out if I have a function such that there is a barrier. Then I can do a binary search and answer. So basically what happens is I have a function of x. Okay. It gives me 0 or a 1. Alright. It gives me 0 if x less than barrier and 1 if x greater than equal to barrier. Okay. So this function is called a check function. Okay. Now, like this is just may in general binary search and answer things. But how do I apply on this question? Okay. Binary search and answer from the term itself, you'll be doing binary search on the minimum possible unsavoriness of the dish. Okay. Let's say what are the possible unsavorinesses? 1, 0, 1, 2, 3, 4, 5, so on. Correct? If 0 is possible, okay, let's say I have 2, 2, 2, 2. Okay. These are my AI. I can make all the BIs too. Okay, so 0 is possible. Even 1 is possible. No? I can just make them 3. I can make all of them 3. And so on. So if 0 is possible, all of them are possible. And let's just give a different example. Let's say 2244. Okay. Still my K, let's say K is still 0. So what is the best case? You'll do 3 here, max plus min by 2. And what is this unsavoriness? 1. Is 0 possible? Can I make 2244? No. Is 1 possible? Yes. If 1 is possible, can I also make 2? If I make 4444, the unsavoriness will be 2. So 2 will also be possible. So basically, this barrier is there, where 1 is possible and all the others are possible, while 0 is not possible. So this is basically the bipartite nature. Like basically, huh. There is a barrier where below it is always no, above it is always yes. There can be reverse also. It can be 1 1 1 1 and 0 0 0 0. Both ways it works. Okay. Now, how do I figure out if this is my unsavoriness? Check if it is possible to do. How do I do this? Is the question. Max. Yeah. So for this is where the check function comes in. Okay. And I'll explain the check function with the help of an example here only. Let me just copy this. Okay. Here, what's the answer? 19 is the answer. Okay. Let's just take this answer and then I'll tell you how the check function is working. Okay. Since the answer is 19, what does my check function need to return? F of 19 equals true. Fair enough. And what is my K? K is 1. Now I'll do this greedily to check if it is true or not. How will I do this greedily? Let's say I'm taking first number 120. I can directly make 120 as 120 and my max diff is still less than equal to 19. So I can go ahead. Fair enough. Here I can make a 120 if I'm just considering this number. Now let's consider these two numbers. What is max? Max equals 120, min equals 100, best t equals 110. Then I check. 120 minus 110 is 10. 100 minus 110 is 10. So this is good. Cool, continue. Now we continue. Now we go on to this. What is the minimum? What is the maximum? Ah, sorry. Ulta. What is the best temperature? 82 plus 120, 202, 101. Okay. Now let's check the difference with max and min only. I don't need to compare with 100 because as I said, max and min only matter. So what is 120 minus 101? 19. What is 101 minus 82? 19. So both of them are 19. So this is also true, true, valid, valid, valid. Let's go. Same thing for here. Now here max and min don't get updated, right? So this is also valid. Now is this valid? Let's check. Mn equals 74. Best T equals 74 plus 120, 97. Okay. Now the difference is 120 minus 97. This is 23. Oh no, this is wrong. So this is wrong. So what I do is wherever I get a wrong, like wherever I exceed the max difference, I put a barrier here. Okay, this barrier is there now. Then I'll move on. Let's say I have another barrier here. Then I move on. I have another barrier here. Okay. And then I reach the end, let's say. How many barriers are there? 3. I'll check if it is less than equal to k. If it is less than equal to k, then I return a true. Or else I return a false. Does it make sense? Like I did it step by step. If anywhere you were stuck or you didn't understand, just tell me, let me know. Cool, I guess you understood. So yeah, I'll just explain with the code so you have a more clearer understanding. थोड़ा सा code mine is iffy. I'll show you someone else's code also, but so now this is my binary search. Okay, what is my lower bound? My L can be at minimum 0 and at max it can be max minus min. This is the maximum value. Max among alls, min among all, and this type of binary search you do one extra from the possible values. That's why I do plus one here. Okay. Now simple binary search, you do mid. If check mid, I do r equals mid, or else l equals mid plus one, and then I print l. Okay. Very easy, very simple binary search. But the main logic is with this check function. Okay. In the start, my min and max both are same, and my remaining barriers left are k. Now what do I do here? This is a bit complicated. Wait. हाँ, LL best equals mn plus mx by 2 if abs of best minus mn. Hmm. Let's just submit this also. So yep. So what I do is I update the minimum and maximum value. I can do it here. I update the minimum and maximum value. I get the maximum, I get the best value, best t. If this range is valid, I continue, I move on to the next. If it is not valid, I put a barrier here. Basically, I put a barrier here and I start from the current number. Since I'm starting from the current number, what do? I set my min and max as AI and I decrease the remaining count. At the end, I just check if remaining greater than or equal to 0. Does it make sense? Yes, no. If you want, you can just chat. I also fine. Hmm, cool. So I guess that is done. Let's move on to 1, 2, 3. This question basically you're given a set of numbers 1, 3, 3, 2, 2, 3, 3, 3, 2, 2, 2, 1, 1, 1, 3, 3, 3. Let's just say. Okay. You'll perform operations. Let's just make this as 3. Okay. You'll perform operations like you'll firstly let's just explain the question. You'll choose an index such that I minus 1 and I plus I plus 1 is 4. So this 2 is 4, these 2 is 4, these 2 ka sum is 4, these 2 ka sum is 4. So I can choose this, I can choose this, I can choose this, I can choose this. I can also choose this actually. My bad, I can choose this. Yeah, because these 2 ka sum is also 4 and this. Now after I choose that index, what the problem states is I replace AI with 4 minus AI. So what is 4 minus 3? 1, 1, 1, 3, 3, 1. Okay. You keep on doing these operations however many times to find the minimum possible sum of it. Okay. Now some things to note. There are only 1, 2, 3. So 1 becomes what? 3. 2 becomes 2. 3 becomes 1. Okay. Is it beneficial for me to make 1 or 3? No. Is it beneficial for me to make a 2 or 2? No. Is it beneficial for me to make a 3 or 1? Yes. So this is the only place where I'll do an operation. Yes, no. Hello. Don't be dead. Yeah, good. So this is the only place where I'll do this operation. Now, how do I figure out where do I operate and how many times do I operate? That is the question. If I want to make a 3 or 1, okay, what should be my left and right be? It should be either a 1 or 3 or a 3, 3, 1 or a 2, 3, 1. Correct. And yeah, so this is like these are the only 3 cases where I'll do an operation. But now just greedily it won't work. I'll tell you why. But another thing is, let's say I have a streak of 3, okay, like this. What will happen is I'll change this 3 to a 1. Then these 2 also becomes a 4. So I change this 3 to a 1. Then I change this 3 to a 1. Damn, what is happening? I'm left with only 1 3 here. So that is the cool part of the algorithm where you simply, if you have a streak of 3s and a 1 behind ahead, or 1 behind or 1 is here, same thing. Now it just happens in reverse. Okay. Now you remove this, you make this a 1, you make this a 1, and you make this a 1. Cool. So that is what happens if I have a 1 and some continuous streak of 3s. Okay. Same thing if 1 is here or here. But for 2, there has to be only one 3 in the middle. Because if there are two 3s here, the sum never becomes 4. So this is a case where I just need to take care of this. Okay. So what do I know? If streak of 3s and 1 before or after, then how much do I add to my answer? Length of streak minus 1. This is basically, there are four 3s here. So three of them become 1, right? So 4 minus 1 is 3. This summation is 3 plus 3 because the last 3 is left. Fair enough? Or 1 3, or it is like this 2 3 2. Then it becomes 2 1 2. Fair? Yes, no? So they are the only two cases. Now, how do I solve this? I solve this by dynamic programming. There is greedy solution, but I just couldn't come up with it. And dynamic programming, if it works, it works. Uh, I'll explain how my dynamic program is working so that you all can understand it. Okay. First thing is, I'm talking about the streaks. So firstly, I need to convert A to streaks. Basically, where I'll get pure 1 3 2 1, and how many continuous 3s are there? 2. How many continuous 1s are there? 3. How do I build this? I build this by doing this standard, this thing, like basically sliding window, where I have, if my value is equal to previous, I increase my current, and if it is not, then I push back to my streak the previous and the previous current, and I initialize current with 1 and previous becomes y. And at the end, I push back streaks. So streaks basically becomes this form, 1, and then let's say this is 3. So what is happening is, let's say this is the original array. I am compressing this original array into this form. Okay, this is a streak set. Now I'll do DP on this streaks. DP will have n states, basically each index, and the previous value. Previous value can either be 1, 2, 3. So I initialize it with 4. Now if I is n, just return 0, base case. If I've already visited this particular state, return that state. Or else, either I won't change anything. If I don't change anything, जो current streaks का value है with the current streak का size, I multiply and I use the later value of I plus 1, and previous is what? The previous value is, let's say. Now let's say I'm here, okay? Either I won't change this. If I'm not changing this, I'll add 3 to my answer, plus I'll move on to this part of the array. And what is my previous? Previous is still 1 because if I haven't changed anything. So previous is my I of 0. I of 0 is my value. Okay. This is my no change. Now, if previous is 1 and current is 3, previous is 1, current is 3, what will happen? As I said here, this length of streak minus 1 plus 3. Length of streak minus 1 plus 3. And now, in the future, I'll set previous to 1. Okay. Technically, even 3 doesn't really matter, but 1 is just easier. So that Why am I doing it 1? Because let's say I have 1, triple, 3, 1. I'm already making these ones, right? Now I can't make this 3, I can't change this 3 because I don't have a 3 before it. Since I can't change this 3, I'll rather have set it as 1 so that in the future it doesn't affect me. So that is why I'm setting it as 1, previous value. If previous is 3 and current is 1, then I'll subtract the streak, previous streak minus 1 into minus 2 plus the current streak. Since it is just 1, I will multiply it with 1 and my previous value is 1, I move on to the next. And the other case is previous to, next to, current 3 and it is solo. So I less than n minus 1. Previous is 2, next is 2, current streak ka length is 1 and current value is 3. Then I just add 1 to it because I'm changing the 3 to 1. That's it. And then I store it at GP. And at the end of the day, my first value will never be
Didn't,
changed. So I do this. Yes.
what did you do when previous was 3 and current was 1? Can you explain that part once again?
Yeah, yeah, wait. So let's say I have 3, 3, 3, 3, and 1. Okay. What will I end up doing? I'll end up making these all threes 1. Correct?
Yeah, right.
Yeah. But now if I am at this place, I've already counted iska sum as what? 12.
Right.
I
Uh,
need to make this sum as 6.
Perfect.
Correct?
Perfect. Acha,
Yeah.
minus 2 into
Huh,
length
so,
minus 1. Got it.
so that's why I'm doing minus 2 into length minus 1.
Got
So
it.
that
Got
is
it.
just, and the current value also I need to add. So I add the current streak ka length. And since current is 1, I don't need to multiply it with 1. And yeah, that's it. That is the DP solution. I'll look on some other solution so that I think greedy
I did
should,
the same using brute force and greedy as you said, but
yeah.
I don't know how it is not going in square.
Okay, I'll check that code out. But what is Nishan doing? Oh, he's just doing it twice. Damn. Ah, this is more elegant. Okay, okay, fair enough. Instead of this DP shenanigans, the better solution is I just do 1. I go forward, I change this to 1, I change this to 1, I change this to 1, and then I change this to 1. Now when I'm going backward, I change this to 1, I change this to 1. That's it. So Nishan's solution is actually damn very elegant. I didn't think of it for some reason. I don't know why. I did minimum of all these, but I just had to take both the things. Fair enough. Works. So yeah, that is it. This is a very good solution. Instead of me writing this long code with DP, lot of debugging, this is just clean, elegant. Yes. Fair enough. Now let's come to E. This is a very good problem, and very less people solve it. 33 people only. So this has, like, this will be fun. Ouch! Just like that. Okay. Is Nishan 5 star? Let's go. Nishan is 5 star. Still safe. Hmm. So yeah, what was I saying? Let's solve E then. Yeah. E has a very long question, long statement, and you'll get confused a lot of this. But I'll just explain it in very simple terms. Let's say I have a tree. Okay, let's say this is a tree. Okay. You are the person, let's say you're standing over here. You have a power, let's say K. Okay, wait. Forget about you. Let's just talk about how it is working. Yeah. So this entire working I'll explain. Let's say I have a 1 here, a 2 here, a 3 here, a 4 here, a 5 here, a 6 here, a 7 here, an 8 here, a 9 here, a 10, 11, 12, 13, and 14. Okay. What happens is this creates a vacancy. This the one leaves. After one leaves, the maximum amongst the children takes one's place. Same thing after four changes places. Maximum among these, which is 12, 12 takes up here. Same thing maximum, which is 14, 14 goes here. Now four leaves, 12 comes, 14 goes up, 13 goes up. Basically, what will happen is all these numbers will go firstly. Then 10 comes and 11 goes up. Then 10, 11 go away. So this entire part is just gone. And now 3 comes in. 3 का पूरा सब tree gets treated, then 2 का पूरा सब tree is like done. Because everything over here is greater than 2. So I just keep on adding 3, 3, 3. Okay. So 3 goes, then 8 goes, then 9 goes, then 7 goes, then 2 goes, then 6 goes, then 5 goes. Okay, that is the order in which everything is going. That is the overall question. If a permutation is given with this particular tree, you figure out when a person leaves by now let's say you are at this position. Okay, one wait, and do this. 9, 10, 11, 12, 13, and this is 14. Okay. Let's say you are at power 11. Okay, you are here and your power is 11. Firstly, this entire subtree will get done and this value. So how many nodes are done? 1, 2, 3, 4, 5, 6, 7. Do you understand why this subtree? Because all the values are greater than 3. Since all of the values are greater than 3, the pura ka pura subtree gets done. So 1, 2, 3, 4, 5, 6, 7. 7 values are done. Now, you come on to this tree because this is lesser. First 3 gets done, then 8 gets done, then 11 gets done. So 8, 9, 10. You are the 10th one to leave. Okay. If you have a power k and this is your permutation, you are the 10th one to leave. Okay. Now coming to the real problem. You are here, you are assigned some power. Okay. You need to figure out among all the permutations of the values, what is the minimum time I leave? Minimum time I leave. Okay. How do I do this? So let's say I have some k. Okay. Let's say it is 3. Okay. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 nodes, and each person will have a unique value, 1 to n, distinct. Huh. So each value will have a distinct, each node will have a distinct value. Since I want to prioritize this entire path, isn't it beneficial for me to give 14 to the first node, 13 to this part and 12 to this part? Because I can guarantee that this path gets chosen first. Fair enough? Yes, no?
Yes, yes.
Yeah. Now the only thing is, where are the places where 3 might get stopped? It can get stopped here, it can get stopped here, or it can get stopped by this, right? Yes.
Right.
So now, if I give 1 to this and 2 to this, will 3 be stopped by these two? No, right? Because 3 is greater. Below it, it doesn't really matter what it is. If I have a 1 here, 1 will always go after everything else is completed. 2 will always go after 3 is completed, after this entire tree is done. Fair enough. But now here, I'll have to put a 4. There's no other option, right? Because I don't have a k less than something. So this tree, though, I'll have to visit this node. This node will go out before my this node. So my answer basically becomes 1, 2, 3, 4, 5. Answer is 5. So from this overall observation, the intuition might happen. Let's say I have a path, okay, to my root. This is my node. This is you. Okay, this is you. You are happy. You don't have eyes, but you are happy. Okay. Now let's say I have 2 children. This has 1 child. This has 3 children, and this has no children. Okay. This has an entire subtree. This has an entire subtree. This has a subtree. This has a subtree. This has a subtree. This has a subtree. Okay. Now, if I have some k, okay, I'll assign all the values 1 to k minus 1 to these children's, right? These off branches. Correct. But now I can't, like, let's say if my branches are less than k minus k, then what do I do? I just assign, right? Assign 1, 2, 3, 4, 5, 6. It won't really matter because this will be the best path. Fair enough? Yes. Yeah. But the problem occurs if branches is greater. Here it is k minus 1 and it is greater than uh, greater than k minus 1. Now here I have to choose some subtrees to avoid, right? How do I choose? I just choose greedily. Let's say this has 100 nodes below it. This has 10 nodes below it. This has 5 nodes below it. This has 1 node below it. This has 2 node below it, and this has 1,000 nodes below it. I'll prefer to choose these two always because I'm avoiding going to these subtrees. No, I'm removing those nodes only from my potential answer. Fair enough? Yes, no. Hello. Yeah. So what I do this, like this is basically greedy, and how I do this is basically a priority queue. I'll have priority queue of all the subtree sizes. Size 1, size 2, size 3, size 4. Let's say I can choose only two. Let's say I have k equals 3. So I remove these two. All the others will go before me. I don't have any option. So all the others ka sum I take summation of remaining sizes plus path size. That is my answer. That's it. Does it make sense?
जेनिल
Huh.
पता है मेरा डब्ल्यू ए क्यू आ रहा था
Hmm.
एग्जैक्ट सेम लॉजिक पे
Why?
मैं वो प्लस 5 साइज डालना भूल गया
Ouch.
मैं विरम भैया को मेरा सोल्यूशन एक्सप्लेन कर रहा था ना तब मुझे याद आया कि मैंने 2 इनिशियलाइज कर दिया था एंड जो एग्जांपल टेस्ट केसेस था उसमें 2 के डेप्थ पे था लाइक 5 साइज पे तो इसलिए तो
Yes.
इसलिए इसलिए एग्जांपल में करेक्ट आ रहा था देन मैं विरम भैया को एक्सप्लेन कर रहा था तब मेरे को याद आया कि अरे ये तो मैं डालना ही भूल गया फिर मैं वो डाला और एसी हो गया भाई
Ouch, ouch.
ब्रो दैट वाज वेरी अर्ली पता है आई वुड हैव कम टॉप 20 टॉप 15
Top 10, bhai. Not
शिट
even
यार
top
नहीं टॉप
20.
10 नहीं उतना अर्ली नहीं था बहुत उससे लेट था उससे
Bhai,
लेट था
I was top 22.
अरे it took me a long time to implement by very hard
Bhai, it is very easy implementation.
see my implementation go to my profile
No, no, wait. I'll tell you. No, wait, I'll see yours. Congratulations, by the way, on 5 star.
Yo, congrats.
I'm not sure अरे
नहीं
मतलब आने
हो
तो
गया
दो
हो
भाई
गया
हो गया
छोड़
अपडेट
चलो
हो गया
अपडेट हो गया ओ माय गॉड भाई हमें क्या मस्त लग रहा है
प्लस
भाई
फोर्टी
देखने में
सिक्स
क्या मस्त लग रहा है भाई इट लुक्स सो भाई
ये
दैट कलर इज सो
2024
प्रिटी
चाहिए था
भाई दैट कलर इज सो प्रिटी
2024 हो जाता है
भाई
यार
यार एक तो रह गया
2023 is the year I met her so
ओ डैम
जेनिल सर स्ट्रीम
नहीं कोई है नहीं मैं तो ऐसे ही मजाक
यस
कर रहा हूँ
स्ट्रीम इज ऑन बट या अरे वेट आई हैव टू
शिट
चेक
यार
यार आई जस्ट थोड़े से रह गया मैं
क्या
अभी
ओ 5
ओ
स्टार
ऑल
ओके ओके ओके
यस
डूड ऑल्ट से 1974 is still crazy ओके प्रोविजनल रेटिंग में
प्रोविजन रेटिंग है इसके लिए
भाई
मैं वही तो कर रहा हूँ सिमिलर ही है
हाँ
इम्प्लीमेंटेशन
सेम
बट
सिमिलर ही है बट मैंने बस प्रायोरिटी क्यू की जगह सॉर्ट कर दिया
हाँ फेयर नाउ
इन
लेट्स
कॉन्टेस्ट सॉल्व नहीं हुआ थोड़ा बुरा लग रहा है बट स्किल इशू ठीक है
let's explain it to the stream and people who don't know. So firstly, I'll take the input. Now I need to figure out the path, okay? How do I get the path? Basically, if my child has the node n, which is my target, huh? If my node path has a node n, then I return true, okay? And so if my child has n, then I push back to the path. That's it. So what I'm doing is I'm doing normal DFS. Let's say, and this is n. Okay. When I'm going here, I return false. Here I'm returning false. Here I'm returning false. Now when I'm here, I return a true. So I push this to my path. I return a true. I push this to my path. I return a true. I push this to my path. So these all nodes get pushed back. So that is how I get my path. Any doubts here? No? Then cool. Then let's do subtree. How do I calculate the size of subtree? Pretty simple. For each child, if it's not parent, I'll add the subtree ka size. And since I'm doing DFS pehle, the subtree of child gets calculated first, then my answer gets calculated. And it's better not to return here and use it kind of like DP because it's just easier like to debug. That's it. And I initialize answer to 1, so my subtree size gets pura calculated. Cool. Then I also debugged my path and my subtree. And yeah, now I just initialize priority queue. I reverse the path. Now for all nodes in the path, if my current node is my node, my next node is I plus 1. My path is like this, okay? So this is my I plus 1. If I'm here, this is my path, okay? This is basically a bamboo. If I'm this node, the next node is basically I plus 1 only. So this is my next, and my parent is 0 because parent is also required. If my child is not next, not or parent, I push it substrate to my priority queue, and I set parent to my current node. So then it's just normal priority queue stuff. While mn is less than k, starting from 1, and priority queue is empty, I pop and I increment mn. Answer is my path size, and while my priority queue is not empty, I just add the value. That's it, and I print answer. Any doubts? Cool. So I guess that is it. Let's say bye bye to stream. Like, share, subscribe, join Discord. See you next PC.